Okay, here's a fundamental triangle for 2 points. Points are A, B, and X, Y. We don't know what A is, we don't know what B is, we don't know what X is, we don't know what Y is, so we just slop down 2 points. They don't have to be in the first quadrant. They could be anywhere. You don't even necessarily have to have your coordinate axes in the picture. But I put them in here so I could emphasize that for the fundamental triangle, you got the 2 points. Why don't we just go ahead and label it A, B, and label another point X, Y. One could be, the second could be higher or lower, it doesn't matter. Okay? All the expressions you get are going to be the same. So it doesn't matter what quadrant, doesn't matter if it's going up or down, how steep it is, as long as it, yeah, well, we'll stick with that idea, okay? Now, I said you have to choose a direction, okay? Do you want to go from here to here or here to here? You said we'll go from here to here. And usually we'll go left to right. But if we want to go right to left, that's okay. We're going to end up with the same slope, and everything else will be the same. But since we're going from here to here, I'm just going to put arrows on all 3 of these sides so that I've got a path from here to here and another path from here to here that goes this way. Okay? You know, a single straight line path from here to here, or, you know, displacement in the X direction and a displacement in the Y direction that get me to the same point. Okay, well, now let's do this again, and I'll just do this for some simple numbers. Let's say this point is 2, 3, and this point is 5, 4. Okay? And I do the same thing. Arrows in the same direction. How far is it from here to here?
2.
I'm sorry?
Would it be 2?
Okay, well, no, but close.
Oh, 5?
Huh?
5?
No, to get from here to here, you don't have to go 5 units, you don't go 2 units. How many units you go?
4? I'm confused.
Let's think about it. Here's your x-axis. What's the coordinate of this point?
0.
Huh?
Oh, 1. Or,
What now?
I'm confused. I'm like,
Well, if this is the point 2, 3, and this is directly below it,
oh, then it's a 0.2.
it's 2, yeah. And directly below 5, 4 is 5.
Yeah.
Now,
Oh.
what's greater, this distance or this distance?
The same distance.
They're the same.
Okay.
I knew you were going to say that. Okay? Very good. So, same distance, right? Because implicitly, this is a right angle, 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 and this is a right angle, right? So what you got is you got 2 sides of a square. Now going in this direction, if you go from 2 to 5, what's the change in the x value?
3.
And plus 3 too, right?
Yeah.
Not just 3, but plus 3. Distance is 3, but if we go in this direction, we have a displacement, which is 3. So we say that this is plus 3. Now, okay, if this was 783.79 and this was 942.386, how would you calculate the displacement from here to here?
Just subtract
You'd subtract what from what?
the first one from the second one.
Yeah, you subtract where you start from where you end, right?
Yeah.
And we know that. Okay? Okay, so this displacement is, well, it's this minus this. That's what I wanted to illustrate. So when I write out the calculation that I do here, I'm going to write this out as 5 minus 2 equals 3. Now, if I was going in the opposite direction, it would have to be 2 minus 5, which would be negative 3. And that makes sense. If we go in this direction, we're displacing ourselves negative 3 units. Okay. Now, from here to here, what's the calculation for this side?
Just 1.
What's the
Plus
calculation?
one.
That's the result.
Plus 1.
That's the result, that's not the calculation. Calculation here was 5 minus 2, the result was 3.
Yeah.
What's the calculation for this one?
4 minus 3.
Yeah. Okay? Now this is the run. This is the rise. So the slope of course we know is rise over run, which is what?
Which is the 3 over 1.
Yeah. Okay? And we put the 3 next to this. Now, we don't want to just leave the 3 there because that'll look like a distance because, of course, 3 here is a distance and 1 here is a distance, right, or a displacement. Okay? So that might look kind of like maybe the length of this thing or something. So we're going to put a rectangle around it to indicate that it's a slope. That's going to be a convention we use. It's just in this class. Don't try to do that out in polite society. Nobody will know what you're talking about. But in this class, we're going to put a box around that and indicate that it's the slope. Fair enough? Okay, so, okay, what's the run here?
Run here would be, do you want like?
It's got to be in symbols because you don't have any numbers.
It would be a minus x, right?
No, but close.
Or I mean x minus a.
Yeah, that's better. Okay, so you subtract where you are from where you're going because that's the only thing that makes sense. Okay? If you just think about it in terms of mileposts in the interstate or something, you know, you want to know how, well, okay, I'm going to drop that idea, but because I don't want to go into all the detail, but run x minus a, right? What's the rise?
Y minus b.
I'm sorry?
Y minus b.
Yeah. So what am I going to put in the box?
We would do,
It's going to be the slope. What's the slope?
well, if it's, would it just be b over a?
When I ask you what's the slope, you're going to say rise divided by run.
Oh yeah. Yeah.
So what's the slope?
Rise divided by run.
Very good. What's the rise?
B. Or y minus b.
Yeah.
Yeah.
What's the run?
X minus a.
So what's the slope?
Y minus b over x minus a. Oh,
Okay.
I got it. I thought.
Yeah, I know you do. Make sure you keep it. Because that's really the key. You understand it right now, or you're going to understand it when you need it on the test that you're going to take before next week. Okay? Okay, so, and on the homework I'm going to give you for next week. Now, we only have class on Thursday next week. We have enough, you know, we missed a day to snow 2 weeks ago on a Tuesday. We're going to miss this Tuesday because there's a faculty in service. Pretty good in service, so I'm not going to complain. I'd rather have the class time, but it's okay. Okay, well, what else do you want to know about fundamental triangles?
That helps a lot.
Yeah, that's what you need to know right now.
Okay.
You know, you can easily find the length of this hypotenuse by the Pythagorean theorem. Square of this plus the square of this equals the square of this. Well, we'll do that later, but everybody knows the Pythagorean theorem. And if they don't, they will. Okay? And we don't need that right now for what we're doing and what we're going to do in the assignment for next week. But we do need fundamental triangles, and you did a good job of answering those questions. You know, a couple little
Well, I just got like whenever you ask.
couple little bad paths there, but they weren't bad. They were on the right track, and you know, when it came down to it, yeah, you understand that. Okay? As I say, just make sure you maintain your understanding. So I'm going to give you just a minute, or if it takes longer, okay, but I want you to write down what you now understand. Don't just copy the board. You'll have a copy of that on your assignments page. Just write down your understanding of what we just did for your own benefit. So when you see, put slope or put fundamental triangle at the top and write the essential things you have to think about, because I don't know what you have to think about, right? What you know you have to think about in order to do every fundamental triangle right for the rest of your life, if you just take a quick look back at these notes, right?